This course provides an introduction to the basic concepts of artificial intelligence, which is currently experiencing a revival due to several recent advances. The main goal of this course is to provide a broad overview of the field of AI and the many ways that it can be applied to solve problems. We will cover both theoretical foundations and practical applications. What is it? It is a branch of computer science that involves developing machines that can perform tasks that would typically require human intelligence. This includes learning from experience, adapting to new situations, understanding natural language, recognizing patterns, and making decisions. Why study AI? There are many reasons. First, AI is everywhere these days. It is being used in healthcare to diagnose diseases, in transportation to drive cars, in entertainment to recommend movies, and in finance to detect fraud. Second, AI is one of the most exciting and rapidly growing areas of technology right now, and there are all kinds of opportunities to be involved in this field. Finally, studying AI can help you to better understand how intelligent machines work and what the implications are for society. In this section, we will discuss the history of AI, different definitions, key ideas, and important milestones. In summary, the field of artificial intelligence has come a long way since its inception, continues to evolve at a rapid pace. One thing is clear though, AI has the potential to change our world in big ways. Before we get started, I want to say thank you. You are the reason I can make more videos and courses. Now let's continue. As mentioned earlier, one of the goals of this course is to provide an introduction to the basic concepts of AI. In order to do this, we will need to start by discussing some of the theoretical foundations. To begin, we need to answer a simple question. What is AI? There isn't a single universally accepted definition of AI, but one widely used definition is provided by Russell and Norvig, who define AI as the study of mental agents that can reason, learn, and act autonomously. A mental agent is a system that perceives its environment and takes actions based on what it perceives. For example, a robot that can move around and interact with objects in its environment is a mental agent. Reasoning refers to the ability of an agent to draw inferences and make deductions. Learning refers to the ability of an agent to improve its performance over time based on past experiences. And autonomy refers to the ability of an agent to act independently without direct human intervention. The study of artificial intelligence is a highly interdisciplinary field that draws from various branches of computer science and other disciplines such as mathematics, psychology, and philosophy. Computer scientists working in the area of AI often have expertise in multiple subfields, including programming languages, algorithms, databases, and software engineering. Mathematicians working on AI problems may specialize in areas such as linear algebra, calculus, and statistics. Psychologists interested in AI might focus on cognitive psychology, perception, and decision-making, while philosophers working in the area of AI often have backgrounds in logic, knowledge, representation, and reasoning. There are many different types of AI, each with its own strengths and limitations. Some common types of AI include reactive machines. These AI systems are designed to respond to specific inputs in a predetermined way. For example, a chess engine is a reactive machine that uses a set of rules to decide what move to make next. Limited memory. These AI systems have some memory capacity and can use their past experiences to inform their current decisions. For example, a spam filter is a limited memory system that uses past emails to decide whether or not to classify a new email as spam. Theory of mind. These AI systems have a theory of other agents, mental states, and can use this knowledge to make decisions. For example, a self-driving car is a theory of mind system that needs to know where other cars are going in order to make safe decisions about how to drive. Self-aware. These AI systems are aware of themselves and their place in the world. They can use this self-knowledge to make decisions. However, this type of AI does not yet exist. When discussing AI, it is important to distinguish between weak and strong AI. Weak AI refers to programs or systems that perform specific tasks that would typically require human intelligence, such as playing chess or recognizing faces in photographs. Strong AI, on the other hand, refers to hypothetical future systems that would have human-like intelligence and consciousness. Currently, all existing AI systems are examples of weak AI. Another important concept in AI is the difference between artificial narrow intelligence and artificial general intelligence. Artificial narrow intelligence, or ANI, refers to AI systems that are designed to perform a specific task. For example, IBM's Watson, which was designed to answer questions on the quiz show. Jeopardy is an example of ANI. ANI is the type of AI that we currently have, and it is the focus of most AI research today. On the other hand, artificial general intelligence, or AGI, refers to a hypothetical future type of AI that would have human-like intelligence and cognitive abilities across a wide range of tasks. A GI does not yet exist, but it is a common subject of speculation and debate in the AI community. One way to think about the difference between ANI and AGI is to compare them to human intelligence. Human intelligence is general in the sense that we can perform a wide variety of tasks and adapt to new situations that we've never encountered before. In contrast, ANI is narrow in the sense that it is typically designed to perform a specific task and may not be able to generalize to new situations very well. Here is an analogy to help illustrate the difference between ANI and AGI. Imagine you are trying to get a computer to play chess. A program that plays chess well could be considered an AI, because it is designed to play chess and nothing else. Now, imagine asking the same computer to play a completely different game. Say Go. The computer would probably not be very good at Go, unless it had been specifically designed to play that game as well. This is because the computer's intelligence is narrow and task-specific. Now imagine asking the computer to learn how to ride a bicycle. Again, the computer would probably not be very good at this, unless it had been specifically designed to do so, because its intelligence is still narrow and task-specific. However, if the computer were able to learn how to ride a bike, then it would be a good example of a GI, because it would be able to perform a task that requires a wide range of cognitive abilities. The difference between ANI and AG can also be seen when we look at how they process information. ANI systems typically process information in a rule-based way, meaning that they follow a set of rules or an algorithm to make decisions. For example, a chess engine might have a rule that says, if it is your turn and you can capture the opponent's king, then do it. In contrast, AGI would process information more like a human by using a combination of logic, intuition, and creativity to make decisions. Finally, the difference between ANI and AG can also be seen in terms of their capabilities. ANI systems are typically capable of performing only the tasks that they were designed to do, whereas AIG would be capable of performing any intellectual task that a human being can do. To sum up, the theoretical foundations of AI is a vast and complex field that covers a lot of ground. Hopefully this brief overview has given you a taste of some of the key concepts and ideas are central to the study of AI. If you are interested in learning more about AI, I recommend checking out some online courses. With that said, let's move on to the next chapter. So far in this course, we have discussed the definition of different types of AI and the history of AI. In the next chapter, we will talk about machine learning, which is a core component of AI. Machine learning is a type of programming in which the computer is allowed to learn from data rather than being explicitly programmed. The idea is that if you feed a computer enough data, it should be able to find patterns and make predictions about new data without being specifically programmed to do so. For example, say you want to build a system that can predict whether or not it will rain tomorrow. Rather than programming the system to look for specific weather conditions and make a prediction based on those conditions, a machine learning approach would involve giving the computer historical weather data and letting it find its own patterns and make its own predictions. There are three different types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is when a computer is trained on a labeled dataset, meaning that each data point has already been classified or labeled in some way. For example, you might have a dataset of pictures of cats and dogs that have already been labeled as such. An algorithm would then be used to learn how to classify new pictures of cats and dogs. Unsupervised learning is when a computer is trained on an unlabeled dataset. This means that the computer must find its own patterns and relationships in the data. For example, you might give a computer a bunch of data points and ask it to find clusters or groups of similar data points. Reinforcement learning is when a computer is trained to perform a task by interacting with an environment. The computer is rewarded or penalized based on its actions in the environment. Over time, the computer learns what actions lead to the most rewards. Machine learning is being used in a wide variety of applications today, including speech recognition. Machine learning algorithms can be used to convert spoken language into text. This technology is used in virtual assistants such as Siri and Alexa, as well as in applications such as automatic transcription, image classification. Machine learning algorithms can be used to classify images based on their contents. This technology is used in a wide variety of applications, including facial recognition, medical imaging, and autonomous vehicles. Fraud detection. Machine learning algorithms can be used to detect fraudulent transactions by identifying patterns that indicate fraudulent activity. This technology is used in the banking and credit card industries to prevent fraud and protect consumers. Recommendation systems. Machine learning algorithms can be used to generate recommendations for products or services based on user preferences. This technology is used in e-commerce to recommend products to shoppers, as well as in streaming services such as Netflix and Spotify. That's all for the basics of machine learning. In the next chapter, we will talk about deep learning. Deep learning is a subfield of machine learning that involves training artificial neural networks with multiple layers to extract features and patterns from data. This approach allows for the learning of complex nonlinear relationships within the data, leading to improved prediction, accuracy, and performance. One of the key differences between deep learning and traditional machine learning is that deep learning models can learn hierarchical representations of data. This means that they can identify complex patterns and features that would be difficult or impossible to extract using traditional methods. Another key difference is that deep learning models are typically more computationally expensive to train than traditional machine learning models. However, the increased accuracy and performance that can be achieved with deep learning often makes it worthwhile. There are a number of popular deep learning algorithms, including convolutional neural networks. CNNs are used for processing data with a grid-like topology, such as images. They are effective at identifying local patterns and features in the data, and are commonly used in applications such as image classification and object detection. Recurrent neural networks, RNNs, are used for processing sequential data, such as text or speech. They have loops that allow information to persist, and they are well suited for tasks such as language, translation, and text generation. Long short-term memory networks. LSTMs are a type of RNN that is designed to address the vanishing gradient problem. Can occur when training RNNs. They have an improved memory capacity and are commonly used in applications such as natural language processing and speech recognition. With the increasing availability of large data sets and powerful computing resources, deep learning has become a popular choice for solving a wide range of problems in various domains. Some examples of real-world applications of deep learning include natural language processing. Deep learning algorithms